divide radicals. The biggest rule that we have to follow, yes, we want everything to be simplified, but the biggest kind of extra rule is you want no radicals in the denominator. We want absolutely no radicals in the denominator. So if there are radicals in the denominator, we have to fix that. And how we are going to fix that is through rationalizing the denominator. So this little rationalize the denominator. When your teacher next year says that you need to rationalize the denominator, you will be like, oh yeah, Miss Humanek talked about that one day at the end of school. All right? So rationalizing the denominator. And what that basically means is we are going to multiply by a form of 1 to remove the radicals from the denominator. So guys, if everything is simplified and there's only a radical in the top, then you're done. You don't have to worry about it. But if everything is simplified and you still have a radical in the bottom, you need to rationalize it. All right? So this is how we're going to do this. So if you look at A, is everything simplified? Are both those radicals fully simplified?
Yes.
Yes, they are. So guys, both of those radicals are fully simplified. But this square root of 2 is a problem. Why is it a problem? Because it's in the denominator. So guys, the way that we can get rid of this is by saying square root of 2 over the square root of 2. Okay? Because guys, any number over itself is 1. Just like when you simplify, when you want to like make a common denominator in fractions, you multiply by a number over a number, because that's just 1. It's not going to change the value of it at all. It's just going to, rationalize it for us. Now, I did see a couple of y'all pick up your calculator because y'all did a great thing here. You checked, you always want to check it out. Unfortunately, none on this page are going to be nice and pretty. But guys, the square root of 7 divided by the square root of 2, that does not give us a nice pretty number, but it does tell us what it's supposed to be at the end. So now when we rationalize our denominator here, y'all, what happens is we just multiply our radicals across there. So the square root of 7 times the square root of 2 is going to give me the square root of 14. Are you guys comfortable with that? And the square root of 2 times the square root of 2 is going to give us the square root of 4. You guys comfortable with that? So far as we just multiply across. But now, guys, this is where the magic happens. Can we simplify square root of 14 at all? Are there any perfect square factors? Nope. Just 7 and 2, and 1 and 14. So that's still just square root of 14. But guys, what is the square root of 4 simplified to? 2. Isn't that so beautiful? So now we have no radicals in our denominator. We just have that square root of 14 over 2. Let's make sure they're actually equivalent to one another. So I'm going to go ahead and type this sucker in. We're going to do square root of 14 over 2. And would you look at that? They're the exact same weird decimal. So guys, all we have done is gotten rid of that lovely square root. Do y'all see that? And so guys, for a lot of my students, for some of my classes, I'll do the square root of 2, square root of 2. I'll do that as a square root of 4. I think in my honors classes, I can jump straight to 2. Are you guys good with that? That is not me making a radical disappear. It is the math working its magic and making it disappear. So because y'all, and so just as a little reference here, like if I did square root of 3 times square root of 3, what is what's 3 times 3, y'all? 9. So that's square root of 9. And guys, what's the square root of 9? 3. So do I really, I'm just showing y'all, do I really need to write the square root of 9? Because guys, hopefully we can start to understand square root of 3 times square root of 3 is just 3. Just like if I had, I don't know, square root of 7 times square root of 7, what would that give me? Square root of 49, which is really just 7. Does that make sense, you guys? So what I'm going to start to do with you guys in my honors class is skip this middle step here. I'm just going to jump straight from square root of 3 to 3. Are you guys comfortable with that? I'm not just making the radical disappear. The math is making it disappear, which is a beautiful thing. And where that comes in really big handy is when you start to get really big numbers. Like if I had square root of, I don't know, 15 times the square root of 15. Instead of having to multiply that out to get 225, you can just know square root of 15 times square root of 15 is going to equal 15. Does that make sense, guys? Are you guys tracking me on that? So we are going to skip kind of this middle step where we actually show them multiplied out, and we're just going to jump straight to the nice, pretty number without the radical. Okay? And so when you do these problems, now on these were fully simplified before we began. You can do it one of two ways. You can do it by simplifying before you multiply, or you can do it by simplifying after you multiply. Okay? So on B, we have an option here. So, y'all, first of all, neither of these are not fully simplified, are they? Square root of 7 is, but is square root of 8 fully simplified? No. Square root of 8 is also a problem because it's a radical in the denominator, right? So we can either simplify square root of 8 first, or we can get rid of the square root first. What would you guys prefer to do for this problem? Let's try simplifying first, okay? So, and then I'm going to show you what it looks like if you don't. Because you're either going to simplify in the front or the back. So the square root of 7. And then, guys, how can we simplify the square root of 8, y'all? 4 and 2, yep. And so what does that, so the square root of 4 times square root of 2. And so then, Rico, what does that actually turn it into? 2 square root of 2. Okay? So that becomes 2 square root of 2, or 7 square root of 7 over 2 square root of 2. Y'all comfortable with that? Now, what do we need to multiply? Do we have any problems here? Square root of 7 looks good. Square root of 2 is nice and simplified, but, we have a radical in the denominator. So how are we going to get rid of that radical in the denominator, y'all? Square root of 2 over square root of 2. Are you guys comfortable with that? So then, square root of 7 times square root of 2 gives us square root of 14. And then square root of 2, or 2 is on the outside. And then square root of 2 times 2 gives us 2. Are you guys comfortable with that? And then, guys, that becomes the square root of 14 over 4. Do I have any questions about kind of how that works? Do y'all feel good about that? Do y'all see where I got the 2 times 2 on the bottom? The first 2 is this lovely 2 right here. The second 2 comes from square root of 2 times square root of 2. So that's where the second 2 comes from, and 2 times 2 gives us 4. Any questions for me on that guy? Okay, what else could I have done? Instead of simplifying that square root of 8, what else could I have done? Any ideas? What's another way we could have gotten rid of that square root of 8? Square root of 8, exactly. So I'm going to show you guys how I did this in another one of my classes so that you can see I got the exact same answer. If we multiplied by the square root of 8, y'all, that would have given us square root of 56, right, on the top, because 7 times 8 gives you that square root of 56. And square root of 8 times square root of 8 eventually gives you 8, doesn't it? Because that's square root of 64. Well, then we would have had to simplify the square root of 56, which gives you 4 and 14. So that becomes 2 square root of 14 over 8. And that reduces us down into the square root of 14 over 4. Do you get the same answer both ways? Absolutely. You're just either simplifying at the beginning or you're simplifying at the end. Does it make a difference which way you simplify? No. Personally, guys, my preference is to simplify my square roots as much as possible because then I'm multiplying by smaller numbers, and I prefer to multiply by the smaller numbers. But you can always say, oh, if you need to rationalize the denominator, you can just multiply it by itself, and you can just do square root of 8 over square root of 8. Does that make sense? So guys, for most of these problems that we do on this page, there's like 2 to 3 ways to do these problems. So there's like 2 or 3 ways that you can do these. And so I'm just showing you one of them. All right, guys? But there's actually a lot of correct ways to do these problems. Does that make sense? Do y'all see the difference between the two? And you see how they still give us the same answer? Okay? So let's take a look at C here. All right, C. Square root of 3, or 3 square root of 20 over 2 square root of 4. So I would definitely simplify this one first, all right? Because 3 square root of 20, how can we rewrite that square root of 20, y'all? That would be what? Yeah, that 4 times 5. Are you guys comfortable with that? And so that becomes 3 times 2 times the square root of 5. Are y'all comfortable with that? Mm-hmm. And then down here we have 2. And then guys, what's the square root of 4? 2. So this becomes 6 square root of 5 over 4. Is that fully simplified, y'all? Can 6 over 4 be simplified at all? So if we divide them both by 2, that becomes 3 square root of 5 over 2. So that would be our official way that it could be simplified. Do y'all see that? Now, one thing that I wanted you guys to recognize, like I said, most of these you can do 2 to 3 different ways. So check this out, y'all. What is 20 divided by 4? 5. And so would that be left on the top or the bottom, y'all? Top. So that would become 3 square root of 5 on top. And then the square root of 4 would have gotten canceled, so it's just over 2. So guys, if we just did 20 divided by 4, does that give you square root of 5? Isn't that so much easier? But y'all, do we get the same answer both ways? So there's actually even multiple ways to simplify them. You can simplify them by dividing, or you can simplify them by simplifying the radical. All right, guys? So either way, we would have done 3 square root of 5 over 2. All right. So I want to show you guys this one really quick. All right. We have square root of 2 over 2 square root of 3. So guys, I want to multiply that. What's the problem in D? Is it the square root of 2 that's the problem, or is it the square root of 3? Square root of 3, because it's in the denominator. That's our little problem child right there. So we need to fix it by rationalizing the denominator. I wish that I could just do something to rationalize my sweet 3-year-old right now, but that's not the way it works, okay? So this, now we just multiply it across. So guys, what's the square root of 2 times the square root of 3? Square root of 6. And then, y'all, 2 times square root of 3 times square root of 3 gives us 3, because that's really the square root of 9. The square root of 9 is 3. And so this becomes essentially just square root of 6 over 6. And we're done. We can't divide them because they're not both inside radicals, or they're not both outside of the radicals, so you can't simplify them. You can only simplify things you can only multiply and divide things like the inside by the inside and the outside by the outside. Do y'all feel good about that? Does this make sense? Are you guys kind of tracking? All right, I'm going to do one more with you guys, and then I want you guys to do, I'm going to do E, and then y'all can do F, G, and H on your own. Okay? So let's look at E really quick. So let's learn our lesson from C. Can you divide 81 by 2 at all? No, which stinks. But we can turn it into the square root of 81 over the square root of 2. Now, does this help us at all? Can we simplify that square root of 81? What's the square root of 81, y'all? 9. And we are over the square root of 2. Okay, so everything looks simplified, but are we actually done? No, because of that lovely little problem radical in the denominator. So we're going to multiply by square root of 2 over square root of 2 to get rid of that lovely little square root of 2. and that will give us 9 square root of 2 in the numerator. And guys, square root of 2 times square root of 2 is going to give me what? A square root of 4, which is really just 2. Are you guys comfortable with that? So that becomes 9 square root of 2 over 2. And you cannot, 9 divided by 2 does not simplify, so we are done. Are you guys tracking that there? All right. So now what I want you guys to do is I want you guys to do F, G, and H. All right, guys? Based on some of these that we just did. And so I will kind of show you how I would start these. Okay, for F, I would separate them into square root of 5 over 8, square root of 18. And then you could go 2 routes. You could either multiply by square root of 18 over square root of 18, or you could simplify the square root of 18 and try to multiply that guy. All right, on G, I would definitely simplify your top here to be 2 over, not 5, sorry, 10 square root of 3. And then I would worry about simplifying that square root of 3. And over here, on this side for H, there's actually a few ways you can do this. But I would multiply this one by square root of 6 over square root of 6. But there are a few different ways that you can do it. So that's kind of how I would get started on all of these. And then you guys can actually show how you would do them as you go. All right, so please go ahead and do those on your own. All right, guys, so you can see the answers to F, G, and H. And guys, see on this one here, I showed you both ways that it works, right? Where you can do it this way. On G, you could have simplified like Abby did, where you had that 1 over 5 square root of 3. And then multiplied by your square root of 3 over square root of 3. And that would have given you square root of 3 over 5 times 3, which would still be that square root of 3 over 15. So even if you simplified, you could simplify it before, or you could simplify it after, you're still going to get that square root of 3 over 15. All right? So guys, there's a few different ways that you could have done each of these, but there is only one correct simplified answer. So there's a lot of different kind of roads to get there, but there's still only one correct answer. Do y'all feel good about dividing our radicals here? Any other questions? Awesome.